Welcome to all in this YouTube channel Being Engineer. In the last lecture, we have seen what is maximum power transfer theorem, what are the conditions of applying the maximum power transfer theorem, and what is the total amount of the power which is to be transferred from source to load and how it gets maximized. So the condition was RL should be equal to RTH. Load resistance should be equal to the Thevenin equivalent resistance. This is the condition of maximum power transfer. And the amount of maximum power which can be transferred, we have derived VTH square upon 4 RTH. Now in this lecture, we will see some problem based on these two concepts. So look at this first problem. In this, there is a voltage source of 40 volt. There is another voltage source of 20 volt. Two resistances 5 ohm and 10 ohm are connected, and a load is connected R in between. The question is, what is the value of this R so that maximum amount of power can be transferred from both the sources to this particular load, and what is that maximum power? So we have to solve this. So according to this, firstly we have to find out Thevenin equivalent voltage or open circuit voltage just by open circuiting this particular load resistor. As I open circuit this particular load resistor, this is ground and the voltage here is nothing but VTH. So I can apply the nodal analysis over here, one current in this way, one current in that way. So I can write VTH minus 40 divided by 5 plus VTH plus 20 divided by 10, this should be equal to 0. If I solve this equation, I will get twice of VTH minus 80 plus VTH plus 20 is equals to 0. So this is equals to thrice of VTH is equals to 60. So VTH is nothing but 20. Isn't it? After solving this particular equation, we will get VTH is equals to 20 volt. So the voltage here is 20 volt. Now we have to find out RTH. If I want to find out RTH in this problem, what I have to do? Both the voltage sources will be deactivated and we have to look into the open circuited load terminals. Means the condition will be like this. Both the voltage sources get short circuited and we have to see in between the terminals. This is 5 ohm resistor, this is 10 ohm resistor. यदि मैं इन दोनों टर्मिनल को लेके बाहर की तरफ ओपन करूं तो मुझे स्पष्ट दिखेगा कि 5 ohm और 10 ohm का रेजिस्टर पैरेलल में कनेक्टेड है. So RTH is nothing but 5 parallel 10 ohm and this will be equal to 50 upon 15, 10 by 3, that is 3.33. So I am having VTH and I am having RTH. Now what is the value of this R for maximum power transfer? 3.33. And what is the maximum amount which can be transferred from both the sources to this load? That can be determined by the formula P is equals to VTH square upon 4 RTH. I can substitute this value. VTH is 20 का square 400 divided by 4 into RTH is 3.33. I can also put 10 by 3. So this will be 120 by 40, and means 30 watt. Yes, this is equals to 30 watt. So I can say that the maximum power which can be transferred from source to load is equals to 30 watt and the value of R should be equal to 3.33 ohm or 10 by 3. Now look at this particular problem which was asked in the GATE examination earlier in 2011. GATE 2011. In this problem, you can see there is a voltage source of 10 volt value, one resistor of 6 ohm, another resistor connected in parallel or across the 6 ohm resistor. The value is, let's say, R ohm, and this is the load. It is highlighted in the problem. It is given in the problem. This is the load. Now the question is, what is the value of this resistance R so that maximum power can be transferred from this source to this load? तो पहली बार में प्रॉब्लम देखते साथ हमें ये फीलिंग आने लगती है कि लोड रेजिस्टेंस की वैल्यू RL है और RL की वैल्यू 3 ओम है. तो इस केस में RTH भी 3 होना चाहिए। 6 यहाँ है तो ऑब्वियस सी बात है कि R को यदि मैं 6 ले लेता हूँ यानी बी ऑप्शन, तो 6 और 6 पैरेलल में 3 हो जाएंगे और इंपेडेंस मैचिंग हो जाएगी, मतलब लोड का रेजिस्टेंस थेवेनिन रेजिस्टेंस के बराबर हो जाएगा और मैक्सिमम पावर ट्रांसफर होने लगेगी। बट दिस इज नॉट ट्रू। व्हाई? लेट अस फाइंड द करंट इन ईच केस। Actually, maximum power transfer can possible from source to load when maximum current is flowing from source to load. मतलब ये सोर्स है और ये लोड है, यहाँ से यहाँ जाने वाली करंट जब मैक्सिमम हो जाएगी तो पावर भी मैक्सिमम हो जाएगी, because load is resistor, so power is nothing but I square R. In fact, when the load is impedance, then also the power is I square R. So let us find the current in each case. Suppose I take R is equals to 0. If R is equals to 0, this will become short circuited. So only one resistor 3 ohm is there and 10 volt voltage source is there. So what will be the current? 10 by 3 ampere. Let us take another option, 6 ohm. If I take R equal to 6 ohm, 6 and 6 parallel में 3 and 3 और 3 series में 6. So what is the current passing from the source to the load? 10 by 6. 10 by 6 ampere. Now if I take R equals to 3 ohm, what is 3 and 6 parallel में? It become 2. 3 6 18 by 9, 2. 2 or 3, 5. What is the net current? 10 by 5. You can also write 2 ampere. If I take R is equals to infinite, it means it get open circuited. Means 6 and 3 are in series. The total equivalent resistance is 9. So what is the net current? 10 by 9 ampere. So if I look at these options, option A, when R is 0, the current is 10 by 3 ampere. Option B, when R should be 6 ohm, current will be 10 by 6 ampere. Option C, when R is 3 ohm, the current is 10 by 5 2 ampere. And option D, when R is infinite, the current is 10 by 9 ampere. So out of these 4 current, which one is the maximum current? Of course 10 by 3. Which is only possible when R should be equal to 0. So this is the correct answer. What I want to convey you, this is correct, that in any DC circuit, for transferring the maximum power from source to load, load resistance should be equal to the Thevenin resistance. But this is also important that we have to calculate the current from source to load. When it gets maximized, then power transfer will also be maximized. So you should be very careful in solving such kind of problem. कि लोड रेजिस्टेंस थेवेनिन रेजिस्टेंस के बराबर होना चाहिए, लेकिन थेवेनिन रेजिस्टेंस 0 हो गया तो उससे हमारी मैक्सिमम पावर की कंडीशन सेटिस्फाई होती है। ओके, सो इन दिस क्लास वी हैव सीन दीस टू प्रॉब्लम्स व्हिच आर बेस्ड ऑन मैक्सिमम पावर ट्रांसफर थ्योरम. You can practice a lot. So many problems are given in the books like Haidt-Camerley and Van Valkenburg. And one more thing, you have to practice this maximum power transfer theorem as much as possible. Why? Because this is the topic which were asked in the previous years of GATE examination. Very frequently the question on this particular topic asked by the GATE authorities. So you should be very careful about this particular topic. Thank you for watching this video.